Welcome viewers, in this video we will see the details about the Norton's theorem. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Norton's theorem, one of the theorem available in the circuit theory. Norton's theorem is the dual of the Thevenin's theorem. The Thevenin's theorem and problems are available in separate videos. In Thevenin's theorem, the Thevenin equivalent circuit is voltage source connected in series with the Thevenin resistance. In Norton's theorem, the current source is connected in parallel with the Thevenin resistance. That's why this Norton theorem and Thevenin theorems are called dual of Thevenin's theorem. Now we'll see the statement. Any linear active network with output terminals A, B as shown in the diagram can be replaced by a single current source ISC in parallel with the single impedance Z Thevenin or R Thevenin. So in this Norton's theorem, we are going to convert the complicated linear active network into simplified equivalent circuit. This is the linear active circuit, the AB, terminals AB. This is the load terminal. The load is connected across AB. In which we are going to find either load current or load voltage. This complicated circuit is replaced with short circuit current source. One short circuit current source in parallel with the Thevenin resistance. This is the load terminal AB. Right? So in Thevenin's theorem, we have Thevenin voltage V Thevenin in series with the R Thevenin. Here short circuit current source. There voltage source in series with the Thevenin resistance. Here current source in series with the Thevenin resistance. Now we'll see how to find the short circuit current and RTH. What is the procedure to find the short circuit current and RTH? ISC is the current through the terminal AB of the active network when shorted. We need to short circuit this terminal AB. Then we need to find what is the current flowing through the terminal AB. That is nothing but short circuit current. This is a current source. Right? So ISC is nothing but short circuit current by short circuiting the terminal A and B. Then Z Thevenin is the Thevenin impedance. Thevenin impedance means the impedance across AB. When all the sources are removed, both current source and voltage sources are removed, the equivalent resistance across AB is nothing but R Thevenin or Z Thevenin. Right? So the complicated network with the terminal AB is converted into short circuit current source and Thevenin resistance. The short circuit current is nothing but current is flowing through the terminal AB when it is short circuited. And Thevenin resistance is resistance across AB when all the sources are removed. Right. Now we'll see the further description available in this network. The current through an impedance connected to the terminal of Norton's equivalent circuit must have the same direction as the current through the same impedance connected to the original active network. Right? So the condition is available. Current through the impedance connected to the terminal of Norton equivalent circuit should be same as the current through the same impedance through the original active network. Right? Current through the impedance, load impedance must be same as the current through the original network. Then only it is possible. After evaluating the value of ISC and RTH, the current through the RL connected across AB can be calculated by applying the division of current formula, current division rule as expressed below. Right? So after finding the ISC and R Thevenin, we have this final circuit is available. This is the short circuit current source, Thevenin voltage, Thevenin resistance, and the load terminal AB. This load resistance RL, our aim is to find the load current IL. So because of this simplified network, we can easily find the current through the load resistance by using the current division rule. So the short circuit current is flowing. At this point, the current is divided. The current is flowing through the R Thevenin as well as RL. Current is divided here. So by using the current divider rule, we can find current through the RL, that is IL equal to, what is the formula? Total current multiplied by resistance of other network. What we need is current through RL. Other network is RTH. So it is multiplied by RTH divided by total resistance. RTH plus RL. Right? So IL equal to total current multiplied by resistance of other terminal divided by total resistance. In case of voltage divider rule, the resistance of the same network, same arm will be available. Here resistance of the other arm, right? What we need is current through RL means you have to multiply with RTH. In case of voltage, the same resistance is multiplied, right? So by using the current divider rule, we can easily find the current flowing through the load resistance RL, that IL can be calculated. So in the Norton's theorem, the complicated network is converted into current source in parallel with the Thevenin. From that simplified circuit, we can easily find the load terminal AB. Either current or voltage through the load resistance can be easily calculated using the current divider rule. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.